Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at static class members in C++. Now at the moment this is the last really important topic that we need to cover before we can go ahead and start coding a real program. So unless I think of something else, which I might, in the next tutorial we can get on to real programs. So let's take an example here. I'm going to create a class and I'll call it test, and I'll just define it here in the same file as the main function, although normally you put classes in their own header and .cpp source file, but for convenience in this tutorial I'll just define it right here. The actual Eclipse has put in a semicolon after the class definition for me, as well as the closing bracket there, which is very handy. So we've seen that if we gave this class an instance variable like int, I'm going to call it count for reasons that we'll see later on, then every particular object we create from this class, in other words, every time we instantiate the class, every time we create an object from it, because the class is just a kind of like a template, a blueprint, every single object would have its own count. So every object would have its own version of that count variable, which can be set separately for every object, and we've covered that so far in these tutorials. But if you declare a variable static, it means that there's one version of that variable that's shared for all the objects, so the variable becomes associated with the class, not the object. So to see that, let's make this public. So normally you don't make, most of the time you don't make variables public, but to make this clearer, let's make this public, and I'm going to declare it static to mean that it's shared with all objects of this class. It's associated with the class, not with particular objects. Now when we create a static variable like this, we have to initialize it somewhere, because remember, normally this variable will be, memory will be allocated for it, and a value will be probably given to it as well when we create particular objects. But because it's static, we need to do that separately somewhere else. So see, normally this will be in the .h header file, and then we'd have a .cpp file, and we would normally initialize the static member variables in that .cpp file. So I'll normally put this in the CPP file, the bit that follows. And what would type is, we need the type of the variable, and we need to specify the class that it's associated with. We put 2 colons like that, and then the variable name. And here we should assign it a value. So let's set it equal to 7. Now we don't need an object to access this variable because it's not associated with objects. It's shared for all objects and associated with the class. So we could do stuff like cout, test, and again we need double colons now to access it, count, and endler. So we're using the class here, not an object of this class. And let's run this, and we find that we get 7. Now you can also create static methods, and most often you would access static variables in static methods. And again, static methods are associated with the class, not with particular objects. So let's create a public section here, and let's make this private. Let's call this static void show info. So static methods are accessed via the class, and they can only access static variables. If you think about it, you can't access a instance variable, a non-static variable, from a static method, because the static methods as well as the static variables are associated with the class. So there's not necessarily it's not necessarily true that any instance variables are actually in existence. There's not necessarily any objects of this class. There could be, but in this case there aren't. There don't have to be. So because this is static, we can access it in a static method, and we can say cout count. So we don't need any prefix referring to either static or non-static variables when we're actually within the class itself. So now we can call that method via the class because it's static. The actual method is static. So we say test : and I can use the autocomplete, control space here, show info. Let's take a look at that, and we'll run that. And we get 7. So static methods are great, for example, for if you've just got some function that needs to take in some data and return some data, but doesn't actually do anything with any instance variables, then you might choose to make it static. A classic, or I'll show you a couple of classic uses of static variables here. So one use is you can define constants with them. So let's say that we want to define a constant called max for some reason, whatever max is, or it could be pi or something. We can say static int, and now it's traditional with constants to put them in uppercase. So you don't have to, but it's a traditional thing to do to make it clear it's a constant. Let's create a constant called max, and I'm going to make that const, so I need a const keyword in there as well. And because it's const, we can now assign a value to it directly. So we don't have to do this initialization here. For constants, you have to give them a value when they're actually declared, and then you don't need to do this bit down here. So now we could say, for example, cout. Well, let's make this public because if we want to access it from outside the class, and it is quite common to define static constants that are public. That's not a problem. They can't be changed anyway because they're constant. So there's no drawback to making them public. Often you should make them private if they're only going to be used within the class. But often you declare a static constant specifically because you want a constant that you want to be able to access just via the class. So let's take a look at this. We can say test : max and endler. And with a bit of luck, that should work. So we get now 99. Let's just put a note here. Initialization of const can be done, must be done right here. Now, one use of a static variable, there are lots and lots of uses that they are commonly used, but one kind of classic use that you see, for example, on exams is to count the number of objects you're creating. Because remember, static variables are static variables, not static constants, but static variables are not only shared between all the objects of that class, but they can be accessed via all the objects of that class. And because they're not constant, they can be changed by those objects as well. Static constants can be accessed from all the objects, but they can't be changed because they're constant. So let's look at this static int count, and let's initialize it to 0. And let's create a constructor here. So let's say test, it's the constructor. And now we can increment count in that constructor. So let's create some objects from this class. So now if I run the showInfo method, so what's happening is we're not running the constructor here because we're not creating any objects. We're just using showInfo with the class and outputting its value. And the value that's output is the value we initialized it to start with. But look at how that changes if we create an object. Let's say test1. That will cause the constructor to run, because constructors run when you instantiate a class, when you create an object from it, in other words. That will increment count, and then when we do showInfo afterwards, we'll get count equal to 1. Let's run that. So we see that the constructor incremented this shared static count. Remember, there's only one static count variable shared between all objects of this class because it's static. That's the point of static. Let's create another one here. Let's have test2. Now if you run this, we're going to see that now the count is 2. So we're effectively counting how many objects we're creating, which is useful. And quite a common thing to do is to use that count to initialize an ID for your objects. So let's create a non-static field. So int ID. So this is going to be per object, it's not static. What we can do is we can say ID equals count plus plus. So we've actually got two kinds of plus plus operators in C++. If we put plus plus after the variable, its value will be used first, so in this case assigned to ID, and then incremented. If we put plus plus at the start, it will be incremented first and then used. So this version is called the prefix increment operator. The version we had before is the postfix increment operator. Let's see that working. So I'm going to create a non-static method here. So let's say public int get ID, and that's going to return the ID of the object, which we created by using this count. So it's going to be unique because every time we create an object, we increment count and we assign the ID based on that. Whoops, I'm thinking of Java here, typing public twice. Okay, yeah, we need it like this. The public is just a kind of a section in C++. Right, so now we can say here, we've got test1, let's say cout test1.getID. And let's do that after test2 as well. So if we run this now, we see that the test1 object, whoops, I need to also put in endler there. I think I've got everything right here. Let's try it, see if it works. Whoops, did something wrong there. Yeah, I've got the wrong kind of put to operator. Okay, so what we're getting now, I should put some text in to make that clearer. Object1 ID. And let's put that down here as well. So down here, object2 ID. So if we run this now, we see that object 1 has ID 1, object 2 has ID 2. So what's happening is when the class is defined, we initialize count to 0. When we create an object from the class, which we do here, what happens is count is first incremented from 0 to 1 and it's assigned to ID. So that object will always have ID of 1, and that's what we're seeing here. When we create a second object, count is incremented again to 2 and then assigned to the ID of the second object. So the second object's ID is going to be 2. If we use the postfix increment operator, that would first assign the value of count and then increment it. So count would be 0, and the first time it's used, it will be assigned to ID, then incremented, and now our IDs would go from 0 upwards. So the ID of object 1 is 0, ID of object 2 is 1. So as always, this seems very complicated when you just watch a video on it, but if you try it yourself, you'll see it's not that bad. And at the very least, even if you feel that you don't fully understand it, after coding this yourself, you'll definitely increase your understanding of this a lot. It's not rocket science, but it does take a bit of practice to get it into your head. So what I'd recommend is first try defining an object and give it a public static constant variable and check that you can access that via the class. And when you've done that, try to implement the stuff that I've done here. And I'd suggest going through it the way I've gone through it. Give your class a static int count, and then check that you can output count, make it public to start with. Try defining a static method that accesses count, and access the count via the static method. Then try incrementing it in a constructor, and then try defining an ID and assign the value of that ID based on count. Also try to postfix and prefix increment operators, as I've done in this video. So if you try all those things and you get them working, then you'll be well on your way to having a really good understanding of this. So just for a really quick summary of that. So let's say exercises. So define and output a public static constant. Try that. Define and output a non-static field. Output a static field with a static method. Try incrementing static int field with postfix and prefix operators, increment operators. So that's like e.g. That's like count. Postfix is ++, and prefix is ++ at the beginning. And also try assigning object ID based on count. Let's say static count incremented in constructor. So that'll give you a pretty good workout to get you going with this. And of course, if you feel like experimenting, that's even better. So don't forget that normally you put your class in the header file, so it's worth doing that. And put the definition of the methods in a source file, as I showed you to do earlier in this course. If you just do it like this, it does work, but it's just not the usual way to do it, let's say. And don't forget that your static non-constant variables, in other words, your static variables, they have to be initialized somewhere, usually in your .cpp source file like this. Okay, so that's it for this tutorial. We're going to go on to look at a particle explosion program starting in the next tutorial. So until next time, happy coding.